Pharmacokinetics. Is it a new term for you all? I'm sure not. Are we getting started with it? Sure, we are getting started with it today. Today is the auspicious day to know what the body does to the drug. I mean, to know about pharmacokinetics. Welcome all to Is Pharmacology Difficult podcast. I'm your host, Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find, and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Pharmacokinetics is nothing much very complicated, but yes, you may find it tough as a beginner at many spots of description. The drug moves in, the drug moves through, and the drug moves out of the body. Let's get to know all this with the help of audio diagram. Now, there are major 4 pharmacokinetic processes that determine the complete onset and duration of the drug action. And that is why pharmacokinetics is in short known as the ADME. Capital A, capital D, capital M, capital E. The ADME study. A stands for absorption, D stands for distribution, M stands for metabolism, and E stands for elimination or excretion. Now let's start this story. When the drug is absorbed, the drug is in the form of a dosage form. Then the drug is released into the solution. It enters the bloodstream as a free drug. It constantly, reversibly changes its nature to being protein bound here. Now I should tell you beforehand only that there are many fates of the free drug which we will discuss later on. Now let's talk about the distribution and the storage part. Now this occurs at the site of action. The drug is reversibly in bound and free form. It constantly changes in either of the forms. And so does the same thing occurs in the storage tissue also. Now this free drug, it enters into the circulation. Okay, now is the time that we should know what are the different fates of this free drug. It gives rise to excretory products like bile, feces, urine, sweat, saliva, etc. It may undergo biotransformation, which leads to the development of metabolites, and these metabolites, they are again excreted. So I hope you're getting the whole process and the whole diagram in your imagination right, all in a nutshell. Okay? Now why pharmacokinetic study is so important? It helps to determine the route of drug administration, the dose, the peak action of the drug, that particular moment when the drug is in its peak action. Then it also helps to know about the duration of the drug action and a lot many more things which we'll get to know as and on we progress in this field. Now before we get into the main C of pharmacokinetics, let's have a walk on the shore and get to know the biological membranes. Their structure is so peculiar and specific and unique. Now these membranes are nothing but a bilayer of phospholipid and cholesterol. Then there is a complex but specific positioning of various polar and non-polar groups into the structure of the membrane in such a way that it forms the membrane into a continuous sheet, and this particular structure of a continuous sheet, it confers the great qualities of impermeability and high electrical resistance to the membrane. And all this in turn makes the biological membranes a highly dynamic structure Okay, that was all about the structure of the biological membranes. Let's get to the other topic, related one. The drug transport. Yes, this whole drug transport mechanism, it includes two important parts. The first one is the passive diffusion and filtration, and the second one is the specialized transport. Well, these are just the names. We are not discussing the details, but we definitely gonna start off with this, okay? Now let's start the discussion today with passive diffusion. Now in this discussion waves, I want to tell you that concentration gradient is a very important factor. The drug diffuses across the membrane from high to low concentration gradient. This is the commonest mechanism for almost all the drugs. Now the drugs are acting as xenobiotics. Remember the term? I know you sure do that. Yes, xenobiotics refers to the foreign substances of the body. And drugs are, yes, exactly the foreign substances for the body. The simple concept, if you really understand it nicely, is that if the drug is lipid soluble, it will dissolve within the lipoidal membrane. And another rule says that transport rate is directly proportional to the lipid is to water partition coefficient of the drug. So, if the drug is highly lipid soluble, it attains high concentration in the membrane and it diffuses quickly. And yes, if the difference in the concentration of the drug on either sides of the membrane is quite large, it is greater, then that helps to fasten the diffusion process. Got the rules? Got the concepts? I'm sure you did. Well, if you really did not, then you can just rewind and get to it because I was quite slow. But yes, these are important concepts and basic concepts. You need to understand these things in order to get into the complex material related to all these things, okay? Now, next important subject of talk is the pH effect or the pH influence. But that's gonna be taking some time to understand and to be understood. You know, there's a very famous quotation. It goes like, in the end, people are persuaded by not what I will say, but what they will understand. What a remarkable note. Now, with this remarkable note, it's a time to end today's conversation, and it's the right time to chill the weekend for the time being with your awaited desired cup of tea or coffee. Well, mine is coffee for sure. There are no doubts about it. For all the updates and latest episodes of my podcast, please visit www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about the medical sciences, drug information, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you are listening for the first time, do follow me here, whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.